Good morning, students. 12th English medium, chapter number 3, current electricity. Continue. Today we will discuss one important topic, that is cells, EMF and internal resistance. See, chapter number 3, cells, EMF, internal resistance. What is cell? See, we know that current electricity, motion of charges. Okay, when charge flows, they constitute electric current. But how they are in motion, when they come in motion, to bring charges in motion, we have to supply some energy. Okay, and yes, that is electromotive force. Electromotive force means what? Electromotive force is agency which supplies energy to flow of charge. Okay, so EMF, it is in short denoted by EMF. EMF, electromotive force, it is denoted by EMF. Okay, now what is EMF? What is internal resistance? About cell, that we will discuss in this chapter. You already know what is chemical cell. Chemical cell, okay, it includes two electrons, one positive and one negative, and they immersed in electrolyte solution. Okay, yes, we have one such figure. See, what is cell? A simple device to maintain a steady current in an electric circuit is electrolytic cell. A simple device to maintain a steady current in an electric circuit is the electrolytic cell. What is electrolytic cell? It has two electrons. A cell has two electrons, one positive P and one negative N, immersed in electrolyte solution. Okay, so yes, it is electrolytic cell, chemical cell. It is connected with this external resistance R. What is capital R? Capital R is external resistance. Capital R is external resistance. Capital R is external resistance. Okay, so yes, here it is connected with external resistance. Now, what is EMF? What is internal resistance? That we will see. First of all, see, it is electrolytic solution. For example, in lead accumulator, we have this H2SO4. Then yes, we have two ions, positive ion and negative ion, H2 plus and SO4 minus. Yes or no? Such. Now, see, for example, in this electrolyte solution, we will have two types of ion, and yes, these two ions will move in mutually opposite direction. Okay, positive ion will move towards negative electrode, negative charges, negative ions will move towards positive electrode. So yes, there is exchange of charges with electrolyte. Electrodes will exchange charges with this electrolyte. Clear about this? Okay. Now see, as it is positive electron, it is point A in electrolyte. Potential of this positive electron with respect to electrolyte near to it. Okay, near to it. I am taking one point A. So in this solution, potential of this positive electron with respect to this point A in electrode is positive, and I am indicating it as V plus. The positive electrode has potential difference V plus, which is greater than 0, between itself and electrolyte near to it, that is point A. Clear about this? Potential of positive electrode with respect to A is positive. Similarly, potential difference of this negative electrode with respect to this point B, potential difference between this negative electrode in this point B in electrolyte, it is negative, that is minus V, and this less than 0 relative to electrolyte adjacent to AB. Clear about this? Now we are taking first case when charges are not moving. Means current is not flowing. Okay, current is not flowing from A to B, from N to B. Yes, current is not flowing. Simple, current is not flowing from circuit. Okay, so in this case, in this case, current is not flowing from electrolyte, means current flows when there is potential difference, higher potential to lower potential. Current is not flowing means throughout this electrolyte potential is constant. So see, when there is no current, motion of charges, the electrolyte has the same potential throughout. So that potential difference between points P and N, potential difference between points P and N. How to find potential difference between point P and N? Potential of P with respect to A, it is P plus, minus potential of N with respect to B, it is minus Vn. So yes, this minus will become positive. So it is P plus V minus. Clear about this? So when current is not flowing from electrolyte, current is not flowing means potential at each and every point in this electrolyte is constant. Okay, so potential difference between point P and N, it is V plus minus Vn is equal to V plus minus. This potential difference is called electromotive force EMF and it is denoted by E. So what is E? It is V plus V minus. Okay, how to understand by second method? See here, I have connected this cell with this external resistance R, As it is positive terminal, as it is negative terminal, current is flowing I in this direction. Let current is flowing I in this direction. From this resistor, current is flowing from C to B. Yes or no? Yes. From electrolyte, current is flowing from? Yes. Current is flowing from B to A. Yes or no? Yes, it is. Yes, it is. Okay. Clear about this? Clear about this? Okay. So see how we can write. Resistor R is connected across cell. Current I flows from resistor from C to D and from N to P through electrolyte. Okay. Now, if I say this chemical cell, it always have some resistance, some finite resistance due to its material. Clear about this? Okay. The electrolyte through which current is flowing has a finite resistance R called internal resistance due to its material. Okay. Due to its material. Now see, this cell is connected with this external resistance. If I say this external resistance is infinite, consider R is infinite. Resistance infinite. What is relation between current and resistance? Inverse. So if resistance is infinite, current flowing from R is equal to 0. Also current flowing from the circuit is 0. Current flowing from circuit is 0. When if I consider this R, this external resistance infinite, then yes, current flowing from it is 0. Current flowing from resistor C to D is 0. Current flowing from electrolyte from N to P is also 0. Clear about this? So now in this case, if I take potential difference between points P and D, then how to write? See, potential difference between point P and N, V is equal to, first of all, we have to find potential difference between P and N. How to find? See, potential difference between P and A, clear? Plus potential difference between A and B, okay? Plus potential difference between B and N. See here is the question. Potential difference between P and A, potential difference between A and B, potential difference between B and A. Again from figure. See, potential difference between B and A is equal to potential difference between P and A plus A and B plus B and N. Clear about this? And yes, see here it is. Now what is potential difference between P and A? Means potential of P with respect to A. Yes, here it is. Potential of positive electrode with respect to electrolyte, it is V plus. So here it is V plus. Potential difference between A and B, electrolyte. A and B, they are points in electrolyte. And yes, when current is not flowing, potential is constant throughout electrolyte. So A and B, they have same potential. potential difference between them is 0. So potential difference between A and B is 0. Yes, it is 0. Clear about this? Clear about this? Now what is potential difference between this B and N? What is potential difference between B and N? See, this minus V, it is potential of negative electrode with respect to B. Yes or no? Here we have to find potential of E with respect to N. So yes, it will be its opposite, that is V minus. Clear about this? Okay. Minus sign. It is potential of N with respect to B. Okay. Okay, potential difference between N and B. But here it is potential difference between B and N. So it is plus V. So it is V plus V minus. And yes, is equal to it is EMF. Clear about this? So what is conclusion? See what is conclusion. When current I is equal to 0, when current I is equal to 0, current flowing from it is 0. Current is 0. It is called open circuit condition, and in open circuit condition, potential difference between two ends, between two terminals, potential difference between two terminals is equal to EMF. Is equal to EMF. So again, what is EMF? It is potential difference between two electrodes, between two terminals, between two ends when current is 0 in open circuit condition. Now next case is when R is not infinite, it has some finite value. Now, in second case, see, if resistance is finite, this external resistance is finite, then in this case, current flowing from circuit is not 0. Current flowing from circuit is not 0. From this external circuit, current I is flowing from this point to this point, and in electrolyte, now current is flowing from this N to P in this direction. Clear about this? Okay. Now, in such case, again, potential difference between points P and N, V is equal to potential difference between point P and A, potential difference between point A and B, potential difference between point B and N. So, potential difference between P and A is V plus. Simple. Yes or no? Potential difference between B and N plus V. But what is potential difference between A and B? It is minus IR. Why minus IR? See, first of all, what is potential difference? Yes. Internal resistance of this cell. Internal resistance is I. Current flowing from circuit is I. So in this direction, current flowing is I. So what is potential difference between point A and B? What is potential difference between point A and B? Yes, it is IR. Yes or no? Yes, it is IR. But why it is minus? Why it is minus? See, here it is potential difference between A and B. But current is flowing from B to A. B to A. Yes or no? Yes or no? Current is flowing from B to A. B, negative potential. A, positive potential. So if you say, okay, current flows from higher potential to lower potential, but here current is flowing in opposite direction. That's why there is minus sign. Okay, here negative sign for IR. It is potential difference between A and B because current flows from B to A. Clear about this? Okay, again, we know that current flows from higher potential to lower potential. We consider that current positive. Current flowing from higher potential to lower potential, we consider that current positive. But here current is flowing from B to A, lower potential to higher potential. That's why we are taking minus sign. Clear about this? Okay, so yes, it is minus IR. So V plus V minus IR. We know that what is V plus V minus? It is EMF. minus IR. So when current is flowing from circuit, in such cases, potential difference between two ends, potential difference between two terminals, potential difference between P and A, V is equal to E minus IR. V is equal to, it is E minus IR. Clear about this? Clear about this? And this V is called terminal voltage of cell. It is called terminal voltage of cell. Clear about this? Yes. If again I say that current flowing from circuit is 0, means open circuit condition, then for open circuit condition you have to put I is equal to 0. If you put I is equal to 0, then V is equal to E. So yes, you have to remember this equation. You have to remember this equation. When terminal voltage becomes equal to EMF, when terminal voltage becomes equal to EMF, then when current flowing from circuit is 0 in open circuit condition. Clear? So yes, negative sign in IR, it is for potential difference between E and V, and current flows from between. Now, current flowing from this resistor is R, resistance is R. So what is potential difference? See, for this cell is connected across this resistor. So yes, if potential difference between P and N is V, then potential difference across R is also V. Potential difference across resistance R is also V. So we can write V is equal to IR. V is equal to IR. Yes or no? Okay. V is equal to E minus IR and V is equal to IR. Clear about this? So we can compare this two equation. IR is equal to E minus IR. IR plus IR is equal to E. Okay. Then it is R plus R is equal to E. Then I is equal to E upon R plus R. Then yes, you have to remember this equation. Okay, it is EMF, external resistance, internal resistance of cell. It is internal resistance of cell. Clear about this? Now, if I say if external resistance is 0, then I is equal to, it is E upon R, and it is called maximum current. It is called maximum current. Clear about this? So yes, you have to remember this point. Okay, when external resistance is equal to 0, I is equal to E upon R. Internal resistance upon, EMF upon internal resistance. EMF upon internal resistance. It is called maximum current flowing from cell. It is maximum current flowing from cell. Maximum current supplied from cell. Clear about this? Then yes, what is conclusion of this theory? EMF is electromotive force that provides energy to flow charge. Electromotive force is not a force. Hello, it is not a force. It is one type of energy per unit charge. Voltage, potential difference. Okay. So yes, it is V, terminal voltage, E, EMF, I, current flowing from circuit, R, that is internal resistance of cell, and external resistance is indicated by capital R. Clear about this? Okay. Now we will see some questions based on this EMF and internal resistance. Exercise 3.1. EMF of a cell is 12 volt, internal resistance is 0.4 ohm. What is maximum current? See how to indicate EMF. E is equal to 12. Internal resistance is always indicated by small r, so it is 0.4 ohm. You have to find maximum current, I maximum. See, here it is. When I is equal to E upon R, it is maximum current. Then I maximum is equal to, it is E upon R. It is E upon R. Write your answer in comment box. Write your answer in comment box. Next question, exercise 3.2. EMF 10 volt means I can write E is equal to 10 volt. Internal resistance 3 ohm means I can write R is equal to 3 ohm. External resistance you have to find. Current flowing I is equal to, it is 0.5 ampere. Okay. And what is terminal voltage? V is equal to what? That you have to find. V is equal to what? That you have to find. How to find? See, yes, we have equation. We have equation. Okay. First of all, you have to find this. R is equal to what? Then use this equation first. See, here it is. I is equal to E upon R plus R. I is equal to E upon R plus R. I given E, given small r, given capital R, you have to find. Simple. Second question, V is equal to E minus IR. E given, I given, R also given, so you can find what is terminal voltage. Clear about this? Okay, write your answers for I maximum, for I and V in comment box. Okay, now we will see one question based on EMF, terminal voltage, and yes, series and parallel connection of resistors. See, example, question A, compute equivalent resistance, and question B is find voltage drops VAB, VBC, and VC. Okay, you are given one circuit. Okay, yes, see, it is battery having EMF 16 volt. Its internal resistance is 1 ohm. We will indicate internal resistance like this as a small r is equal to 1. And yes, these are external resistance. Point A, B, C, and D. 4 ohm, 4 ohm, 1 ohm, 12 ohm, and here it is 6 ohm. Clear about this? First of all, we have to find equivalent resistance. How to find equivalent resistance? See, from figure it is clear. These two resistors between A and B, these two resistors between A and B, they are in parallel connection. They are in parallel connection. So how to write? See here, 4 ohm, 4 ohm, they are in parallel connection. They are in parallel connection. So what is their equivalent resistance? Their equivalent resistance means resistance between A and B, RAB, is okay, so it is 4 into 4 divided by it is 4 plus 4. Clear about this? Means it is 16 upon 8 is equal to it is 2 is equal to it is 2. Clear about this? So yes, this 4 ohm, they are between A and B. So resistance between A and B is equal to it is 2. Now, what is resistance between point B and C? Yes, resistance between point B and C, RBC is equal to it is 1 ohm. Clear about this? Okay. Third one, this between C and D. This 12 ohm resistor and 6 ohm resistor, they are in parallel connection. Yes, these two resistors are in parallel connection. Then how to find their equivalent? 12 ohm and 6 ohm, they are in parallel connection. They are in parallel connection. Again, this 12 ohm and 6 ohm, they are in parallel connection. Okay, so resistance between them, RCD, is equal to, it is 12 into 6 upon 12 plus 6. 12 into 6, yes, it is 72. Yes, 12 plus 6, 18. 18 into 2, yes, 18 into 2, 36, and 36 into 2, it is 72. So this answer is, it is 4. Clear about this? Clear about this? 4 and 4, parallel, it's equivalent to, it is 1. 12 and 6, so 12 into 6, 72. 12 plus 6, 18, and 18 into 4, that is 72. Clear? Now, I can draw another figure. See, how to draw this figure? How to draw this figure? Okay. Okay, now we will draw this circuit again. How to draw? See, between A and B, between B and C, and between C and D. Yes, it is battery having 16 volt. EMF, it is internal resistance. Yes, here it is. It is E is equal to 16 volt. R is equal to, here it is 1 ohm. Okay, it is point A, it is point B, it is point C. Okay, now what is resistance between A and B? Yes, resistance between A and B is 2 ohm. What is resistance between B and C? Yes, between B and C it is 1 ohm. What is resistance between C and D? Yes, it is 4 ohm. Clear? So now it is simple circuit. Now, what is equivalent resistance between A and B? So see, equivalent resistance between C and D, is R. A is R, that is our equivalent resistance. And see, from figure it is clear. This 2 ohm, 1 ohm and 4 ohm, they are in series connection. So yes, we can write 2 ohm, 1 ohm and 4 ohm. They are in series connection between A and D. Okay, so yes, what is that series connection? R is equal to, here it is 2 plus 1 plus 4. So 4 plus 1 it is 5 and plus 2 it is 7 ohm. So yes, it is your final answer. Okay, what is equivalent resistance between A and D? Equivalent resistance between A and D is 7 ohm. Okay, so yes, first answer we got 7 ohm. Now we have to find potential difference. To find potential difference, first of all we have to find what is current flowing from circuit. What is current flowing from circuit? And see, current flowing from circuit. Current from circuit or current from cell. Current from cell. I is equal to, yes, we have obtained its equation. I is equal to, it is E upon R plus R is equal to, what is value of E? Value of E is equal to 16. What is capital R? That is total resistance between A and D. Total resistance between A and D. Yes, I can represent this circuit as like this. Total resistance. Here it is R. Here it is battery. Here it is internal resistance. Clear about this? It is E, it is R. Current flowing from it is I. Clear? Okay. So current from cell I is equal to E upon R plus R is equal to 16. What is value of R? 7. What is value of internal resistance? 1. So it is 16 upon 8. So it is equal to 2 ampere. Is equal to, it is 2 ampere. So yes, value of this current I is 2 ampere. Clear about this? Now we have to find potential difference VAB, VBC and VC. VAB, VBC and VC. And also current from each. Then how to find? See, first of all we will find potential difference across each resistor. See, potential difference between A and B. Potential difference between A and B. See, here, with this battery, this all resistors are in series connection. And in series connection, current flowing from each resistor is same. Yes or no? Yes. Then, for potential difference between A and B, we know what is resistance between A and B. RAB is equal to, it is 2 ohm. Okay, current flowing from it is 2 ampere. Yes or no? Current flowing from this is I 2 ampere. So what is potential difference? VAB is equal to I into R, means it is 2 into 2 is equal to, it is 4 volt. Is equal to, it is 4 volt. Clear about this? Clear about this? So what is potential difference between points A and B? What is potential difference between points A and B? Yes, it is 4 volt. It is 4 volt. Clear about this? Now, between A and B, we also have to find what is current flowing from each resistor. This 2 ohm is parallel combination of 4 ohm and 4 ohm. 4 ohm and 4 ohm. Yes or no? Yes, two resistors. This 4 ohm. Okay, between A and B. 4 ohm and 4 ohm. They are connected in parallel. So what is current flowing from this resistor and from this resistor? How to find? Between A and B, potential difference is 4 volt. So between these two ends of resistor, what is potential difference? 4 volt. In parallel connection, potential difference is same. In parallel connection, potential difference is same. So VB is equal to 4 volt, means between two ends of this resistor, voltage is 4 volt. Also between end of these two resistors. Clear about this? So how to find current? Okay, how to find current? Let current flowing from this is I1 and current flowing from this is I2. Then how to find current? So yes, I1 is equal to, it is VAB upon, what is its resistance? It is 4. VAB is 4 divided by 4, it is 1 ampere. So yes, current flowing from this resistance is 1 ampere. Clear about this? Similarly, what is current flowing from this resistor 4 ohm? Potential difference across its two ends is, yes, again it is VAB, its resistance, it is 4. So yes, it is 4 upon 4 and your answer is 1 ampere. Your answer is, it is 1 ampere. Clear about this? Clear about this? Yes or no? So yes, it is all about between points A and B. Between points A and B, total resistance is 2 ohm, current flowing is 2 ampere. So between A and B, potential difference is 4 volt. Between A and B, two resistors are connected in parallel. So what is current flowing from each? 1 and 1. Hello students, you know in parallel connection current is distributed. So yes, current coming from this point is 2 ampere and now this 2 ampere is equally distributed in two resistors because the resistances are same. So 2 is equal to 1 plus 1. Clear about this? Now, yes, it is between A and B. Now between B and C. See. Between B and C. Yes, what is total resistance between B and C? RBC is equal to 1 ohm. What is current flowing from that? Yes, current flowing from BC. It is also I, means it is 2 ampere. Then what is VBC? Potential difference. Yes, VBC is equal to I into R, means it is 2 into 1 is equal to, it is 2 volt. Is equal to, it is 2 volt. Clear? And yes, from this current flowing is 2 ampere. So between B and C it is easy. Yes or no? Yes. Now between C and D, between C and D, what is equivalent resistance between C and D? Yes, it is 4 ohm. What is current flowing between C and D? Yes, I is equal to, it is 2 ampere. Then what is VCD? Yes, VCD is equal to 2 into 4 is equal to 2 into 4, it is 8 volt. Is equal to, it is 8 volt. Clear about this? Okay. Now between C and D, yes, we know between C and D circuit is like this. Between C and D, between C and D, it is C, it is D. Current coming from here, it is 2 ampere. Okay, it is 12 ohm. Yes, it is 12 ohm and it is 6 ohm. What is potential difference between point C and point D? 8 volt. Means potential difference across this resistor is 8 volt. Potential difference across this resistance is 8 volt. Okay, then how to find current flowing from them? Okay, let current flowing from here, it is I3 and current flowing from here, it is I4. Then how to find I3? I3, current flowing from it. Current is equal to potential difference upon resistance. Between two ends, potential difference is 8. Resistance is, it is 12. Yes or no? Yes or no? Yes. Then it is 2 by 3 ampere. It is 2 by 3 ampere. What about I4? Current flowing from this 6 ohm resistor. I4 is equal to potential difference across this resistor is 8. Resistance is 6. Then it is 8 by 6. Then yes, I can write 8 by 6 means it is 8 by 6 means it is 4 by 3. It is 4 by. Clear about this? Now see more interesting result. 2 by 3 plus 4 by 3. Then it is 6 by 3 means is equal to 2. Yes, current passing from point C. Clear about this? Clear about this? So yes, it is potential difference across VAB, VBC, VCD and current flowing from each and every resistor. Current flowing from each and every resistor. See in figure here it is. What is current supplied from cell I is equal to 2 ampere. It is 2 ampere. Yes, it is 2 ampere. Current flowing from this resistor is 1 ohm and here it is 1 ohm. See, according to law of conservation of charge, 2 ohm is equal to 1 ohm and 1 ohm. Here they will recombine again. So current flowing from this is, it is 2 ampere. Yes, it is ampere. Yes, it is ampere. Then this current is again divided in these two resistors. What is current flowing from 12 ohm? It is 2 by 3 ampere, and here it is 4 by 3 ampere. Clear? And again it will be 2 ampere. Again it will be 2 ampere. Clear about this? So yes, it is how you can observe, okay, what happens in series and parallel connection. Okay, now how to verify your answer? How to verify your answer? What is EMF 16 volt? What is potential difference between A and B? Yes, here it is 4. Yes, here it is 4. Potential difference between B and C? Yes, here it is 2. Plus potential difference between C and D? Here it is 8. So it is 8 plus 2, 10 plus 4. It is 14. It is 14. So EMF is 16 volt. Then where is 2 volt remaining? That voltage drop is across internal resistance of cell. See, current flowing from this cell is also I is equal to 2 ampere. So voltage drop across internal resistance, internal resistance of cell is equal to, current flowing is 2 and its resistance is 1, so is equal to 2 volt. And now if you add 4 volt plus 2 volt plus 8 volt plus 2 volt, you will get 16 volt. You will get 16 volt. Clear about this? So yes, it is one question based on EMF, internal resistance, series and parallel connections of resistors. Series and parallel connections of resistors. Yes, dear students, in this time, yes, you are safe at home. We are doing very hard work for you. Now it's your time. Okay? At home, you have to study well, work hard. Good morning, students. Yes, one more example. Exercise 3.21. Yes, you are given a circuit. Okay. Yes. See, this circuit is infinite, up to infinite. Okay. This circuit is repeated to infinite. It is connected to a battery having EMF 12 volt and internal resistance 0.5 ohm. Your question is, you have to find what is current supplied from battery, what is current supplied from cell. See, what is equation? Yes, we know I is equal to E upon R plus R. Capital R plus small r. Small r is. Now what is capital R? Capital R means equivalent resistance between these 2 points A and B of this whole circuit. Okay, now as this network is infinite, if we add or we subtract a loop, then yes, its resistance becomes almost the same. What to say about this? See here, yes, these resistors, how to draw this figure? See how to draw this figure. Resistor, one loop. Then see, this type of loop is repeated here. 1, 2, again 1, 2, 3, repeated. Yes or no? So yes, such loop is repeated. Okay, and it becomes network of infinite length. Okay, so we have to find its total resistance. How to find its total resistance? See, first of all, I am assuming resistance between A and B. Let resistance between A and B is X. That resistance between A and B is X. Clear about this? Okay. Now, if from this infinite network, if we add or subtract one loop, equivalent resistance remains equivalent resistance remains same. Okay, now what is meaning of this? See, what is equivalent resistance between A and B? Equivalent resistance between A and B is X. Now if I add one loop, see, it is loop, one loop, okay, with this A and B, with this A and B, yes, it is R, and here it is R. Now what is value of R? R is equal to, it is 1, okay, and we form another loop, that is PQ, another circuit, that is PQ. Clear about this? Clear about this? So see, actually we want to find what is equivalent resistance between A and B, but for infinite network, if we add or subtract one loop, then equivalent resistance remains same. So now, between this point A and B, one extra loop is connected, and now the endpoints are P and Q. Endpoints are P and Q. So what is equivalent resistance between points P and Q? Yes, equivalent resistance between P and Q is also X. Clear? Because this X is resistance of infinite network, and if I add one more loop, its resistance almost remains same. Now observe this figure. Okay, equivalent resistance between P and Q is X. So how to write? X is equal to this four resistors R, and X. See, from figure it is clear. Okay, this X and R, they are in parallel connection. So what is the equivalent? It is XR upon X plus R. Clear about this? This X and R, they are in parallel connection. So what is the equivalent? XR upon X plus R. Okay. Now this R, the equivalent is XR upon X plus R, and this R, they are in series connection. So between P and Q, first, second, and third. They are in series connection. So X is equal to, it is R plus XR upon X plus R, and plus here it is R. Clear about this? Okay, R plus XR upon X plus R plus R is equal to equivalent resistance between P and Q is X. Okay, now we have to simplify this. See how to simplify. Okay, X into X plus R is equal to R plus R, it is 2R into X plus R and plus XR. Quit out. Okay, now here it is X square plus XR, X square plus XR is equal to this side, it is 2RX plus 2R square plus XR. Any doubt? Okay, so this XR cut. Okay, so X square minus 2RX minus 2R square is equal to 0. Now it is quadratic equation. How to solve this quadratic equation? If you know this equation, see what is general formula? Ax square plus bx plus c is equal to 0. Then what is value of x? X is equal to minus b plus or minus under root b square minus 4ac upon 2a. Okay, yes, here for our equation we have to find what is value of a. Here a means coefficient of x square. So here what is value of a? A is equal to 1. B means coefficient of x. So here what is value of b? It is minus 2r. C means constant term. So c is equal to, here it is minus 2r square. Clear? So now put in equation, x is equal to minus, what is value of b? Minus 2r. Plus or minus b square means minus 2r square. So it will become 4r square. Minus 4. What is value of a? It is 1. What is value of c? It is minus 2r square. Divided by, here it is 2. What is value of a? It is 2. Yes. Then x is equal to, it is 2r. Plus or minus under root 4r square. Minus will become plus. 4 into 2, it is 8r square. Any doubt? Okay, divided by here it is, okay, so x is equal to it is 2r plus or minus 4r square plus 8r square, it is 12r square under root 12r square divided by 2. So yes, you can write this as 2r plus or minus 12 means 4 into 3. 12 means 4 into 3. So it is 2 root 3. 4 12 means 4 into 3. So here it is 2 root 3 r divided by 2. So this 2 and 2. Correct? Then what is value of x? X is equal to here it is r plus or minus root 3r. R plus or minus root 3r. Now plus or minus means yes, we have two probabilities. First, x is equal to r plus root 3r and x is equal to r minus root 3r. Now see, what is r minus root 3r? You know what is value of root 3? 1.73 approximately. Okay, then r minus 1.73r. Hello, yes, you will get minus 0.73r, and it is not possible. Resistance in negative value is not possible. So yes, what is your answer? Your answer is x is equal to it is r plus root 3r. Now x is equal to, what is value of r here? It is 1 ohm. Then it is 1 plus, it is root 3 into 1. So it is 1 plus 1.73. So here it is 2.73 x ohm. Okay, clear about this? So what is equivalent resistance between A and B? What is equivalent resistance between A and B? Yes, it is 2.73 ohm. And now if you want to find current, then I is equal to E upon x plus R. Because between A and B equivalent resistance is x. So now what is value of E? E is 12 volt divided by what is value of x? It is 2.73 plus what is value of internal resistance? 0.5. Yes, calculate this and write your answer in comment.